video we're going to deal with a more complex model, and we're going to introduce three new blocks. We're going to introduce a summing gate, and the summing gate essentially just execute a mathematical operation, so like arithmetic operation, sum, subtraction, multiplication, division, average, minimum, maximum. And then we're going to introduce the logic gate, which, as the name suggests, is going to execute a logical operation. In this case, we set it to XOR. The condition is true for exactly one incoming path. And the logic gate is a multiple input, single output. Unlike for example, the branch gate, which is a single input, multiple output. And the last block that we introduce is the stop flag that will basically help us to terminate the program. So how does this model work, and how can we verify that it actually works correctly? So this model, essentially, drawing from the previous exercise, we're going to extract a number in the range 0 to 360, and which represent an angle. And we're going to put it through a table where we're going to read the appropriate DIDT, but because some of the numbers will be negative, we're going to rectify them, and we're going to put them through the summing gate. And then we use this conditional gate to tell us if we've gone through the loop 3 times. And the number that we extracted, we're going to write it temporarily into a table with this table set value function. And then we use the counter to just increase. And then we jump back to start again. We jump back to start, we execute this loop, we do it 3 times. Once we've done that, we put it through this filter that is going to help us to take this value that we wrote, these 3 DIDT that we wrote, and eventually we're going to put them through our branch gate, which will tell us where they're going to be stored, whether it is the test fail or whether it is the test is okay or is absolutely fine because we are sort of in a green zone with very low DIDT. Obviously we've got to do that 3 times, and the way of getting out of it is use the stop flag that help us to terminate the program. But as I said, if we were to simulate the layout, we would just basically see the results at the end, which could be fine because we got an array of results. Like here, we're going to store an array of results. But we want to see if the logic is correct, because when we start having complex function written, it's important to see that the actual logic is correct. So how can we do that? Well, fortunately, we got this icon, which is a debug. So we click on that, and that gives us a view of our layout. And then we got this step into that enables us to initialize the variable that we set, and that enables us to follow one step at a time if the logic is correct. And it tells us what numbers also is generating based on whatever function is associated to the block. So we can see that, and we can see what happened at each step. So we can follow this as it happens step by step, or we can run the entire sequence, given it's only 3 of them. We can run the entire sequence in full automatic mode and see the layout if it's actually correct. So we can see we've gone past through the first part of the diagram. Now we're on a second part where we actually retrieve the value that we store and we put them into the array, and at the end of it which terminate with the stop flag. So once we're happy with that, obviously we can simulate and get our results, and that's it.